Have you ever been in a situation that you need to make an optimal decision based on some criteria and some options that you're gonna choose from those? How do you make a perfect decision, an optimal decision based on your data? This is about today's video. I'm gonna show you how you can make optimal data-driven decisions, how we can use AHP and TOPSIS method together in order to make a perfect optimal decision. Every engineering concept needs a perfect case study for better demonstration. Today's case study or example is about a logistic management decision. So the management needs to find the optimal choice between multiple suppliers and how we can find the best one that is completely aligned with our business goals. Before we start, don't forget that this method can be applied in various situations, from life decision making, business decision makings, and maybe even find your optimal girlfriend across your options. Therefore, you can change the concepts based on your problem, reverse engineer it into the decision criteria that you might have. Since there are some mathematical operations involved in this procedure, I'm gonna add today's template in the description and you can use it for your own problems, make it personal, make it customized for your case. Let's start. We have 5 different suppliers and 5 different criteria. Let me show you a brief about today's problem. The first criteria is cost, which is the final price that we are gonna pay in order to get the goods from the supplier. So as this becomes lower, it is more perfect for us. We are looking for the lowest cost possible, or maybe avoiding the highest prices as well. Next, we have lead time. This is the time that may take in order to the goods from supplier ships to our plant, our factory, our business, and this is considered in days. So a lead time of 9 days means that it may took 9 days in order to the goods to be shipped in our place. Third criteria is quality, and as you can see, the quality is changing between 0 to 10, and as you can see here, almost all the suppliers have good quality. The minimum quality is 7.9 out of 10, which is good. Be careful about the criteria that you have. Some criteria are negative in nature, meaning that we are gonna look for minimizing their values in order to be more desirable, whereas some criteria are positive in nature, like for example the quality that we mentioned. As the quality goes up, it is more desirable for the business to choose that option from that criteria. So be careful with the negative ones and the positive ones that could have some meaningful impact on your calculations, which we're gonna see in a moment. After quality, we have technical capability from 0 to 10. This is also a positive criteria. As it goes up, it is more desirable. And finally, for the net terms, this is the number of days we have to pay after we have put our order for the supplier and the invoice has been issued. So as it goes up, it is better for us. We're gonna pay later and it is more financially healthy. Now, what is our methodology here? First, we're gonna use AHP to assign some weights to each of these criteria that you saw earlier. Next, we are gonna use TOPSIS to order these suppliers based on how desirable they are or how avoidable they should be, and we should not make any business with them. The output of AHP is a vector of weights, which we are gonna use next in TOPSIS. I'm gonna show you what is TOPSIS in a minute. So in short, the AHP is about how much each factor matters. The TOPSIS method, for the name, we have to use a truck in order to carry the name. The name is very big, and it is for ranking and selection method. The core function of TOPSIS is to measure how close each option is to the ideal best and ideal worst. Literally, what we are gonna do with TOPSIS is to measure the distance from the ideal best to the ideal worst, and we're gonna use Euclidean distance formula. The output would be a closeness score, and that would be our final ranking for our suppliers. So here we have our 5 suppliers, and as you can see, this is our 5 criteria. Each supplier has its own attributes, and this was given as the problem of today's video. I know there might be some freaks among you guys and might ask, why these numbers, why don't we have other numbers, for example. There are some ways that we can find these numbers, quantify them, but is out of today's scope. But it is possible to quantify some qualitative indexes or criteria and have some numbers. The cost is not negotiable, the cost is provided. You can ask the manufacturer, the supplier. The lead time can be averaged out through some previous historical data. The quality can be obtained from the customer side. We can put them on a survey to see how they feel about some product, or maybe some quality checking methods can also provide this value for us. And we could have the same for technical capability and net terms. Those can be obtained from previous data. Okay, so the first step is to make AHP pairwise comparison matrix. This is the matrix that you're seeing here. So the first step is AHP pairwise comparison matrix. As you can see, we have that matrix here, and we're gonna compare them paired together one by one to see how important is a factor versus another factor or criteria. Let's fill this matrix together. An important note is that the diagonal of the matrix is always 1, because we are comparing cost against cost, lead time against lead time, and that's 1. We cannot change that. And also we are gonna only fill in the top part of the diagonal, as the below part can be calculated by division by 1 of the top part. Let me show you how. So let's say the cost is very important for us, and for the cost against lead time, I'm gonna use the SATIS 1 to 9 scale. As you can see here, we are gonna use 1, 3, 5, 7, and 9 for our scoring, meaning 9 is extremely important versus another criteria, and 1 is equally important, not much. The cost against lead time, I'm gonna say, for example, 7 is good for starting. Cost against quality, I'm gonna say about 3. Cost against technical capability, this is 7, and cost against net terms, I'm gonna use 5 to have good answers. For the technical capability against net terms, I'm gonna use 1/3 in here. That is because the net terms, I believe it's more valuable than the technical capabilities, and this is why I'm gonna use 1/3 here. So be careful whenever you're comparing some criteria. If the latter criteria is more important, you have to perform a division and put the divided number there. Now that we have the top part of our matrix above the diagonal, we can calculate the below section by division by 1 of the top elements. Okay, so by now we have our matrix deployed. Be careful when you are scoring these values pairwise together and comparing them. You can perform some questionnaires in order to find relative differences between these values. You can ask the experts for these criteria. For example, you can ask your senior manager about the lead time versus cost importance to see which one is important. I just fill in for the demonstration and for the educational purposes. So the AHP is done. I'm gonna make it green. Now we have to normalize each of these elements into our normalized AHP matrix. For the normalization, first we're summing up each column's values. For example, you can see here that this is sum of the first column, this is sum of the second column, and so on. Now that we have the sum of each column, we can divide each element to that sum of the values to obtain the normalized values here. And finally, we are gonna average out to the each row in order to find the average of rows. This is our AHP weights on the average of rows section, and as you can see, the sum of these values are equal to 1. So this would be our weights for each criteria as the output of our AHP method. Now let's proceed with TOPSIS method. First, we're gonna again normalize the values for TOPSIS procedure according to the formula. First, we're gonna perform a summation on the rows of our data. Here you can see the sum of rows. Next, we're gonna square each element, and as you can see here, we have the squared values of each element for that matrix that we had, or the supplier's characteristics. After that, according to the formula, we're gonna perform again a summation on the rows. The square of elements would be normalized by the sum of square of rows. As you can see here in this section, I divided the square of that element by the sum of square of rows. Next, we're gonna apply the weights that we calculated from the AHP method into the TOPSIS normalized vectors. By that, we have here, let me show you the formula. We have the TOPSIS normalized elements here, as you can see, the cost, and I have multiplied this value by the weight of the cost criteria. So this is our TOPSIS with AHP weights applied on it. By now we have almost done about 80% of our analysis. Now we need to find what is the perfect and optimal desired state of each of these criteria and what is the worst one. By that I mean, let's rewind to the first of this video. We had some criteria that were positive in nature and some were negative in nature. So for the positive, first we need to accumulate the A plus or the desired values, and next the A minus or the avoidable values. For the desired ones and the cost criteria, we're looking for a minimization procedure on the values that we have calculated. This is because as cost goes lower and minimized, it is more perfect, more optimal for our task. And this is the same for the lead time, but for the quality, we're looking for maximum. For the technical capability, maximum is better, and for net terms, again, the maximum is better. The max is always better. Now for the negative or A minus part, we are just gonna do vice versa of the previous section. So for the price, we're looking for maximized, which is the worst case scenario, and for those positive values, we're gonna use minimum or min operation in Excel. After the A plus and the A minus has been calculated, next we're gonna use Euclidean distance formula to find each supplier's attributes from our perfect situation and from our worst situation, that is A plus and A negative or A minus. So here I'm just deploying the formula, do it for all the values that we have here. By calculating this distance formula, we then aggregate the values using the formula for S plus and S minus. Finally, we use this S plus and S minus to form our relative score or relative closeness score, which is our final score to see who is better in our case. As you can see, we have the formula deployed here for S plus and for the S minus or S negative. Ultimately, we have the scores for each supplier here based on the formula that we have. Now, based on what we discussed, you can see here that at the final score section, we have the supplier E to be our first choice for this complex task. Now, if the supplier E ghosted you or maybe left you on red, you can switch to supplier B. Supplier B is our second choice for this problem. Now let's see who was the supplier E. As you can see here, supplier E was not the lowest price option. It has the lowest lead time, okay? It has a relatively good quality. It has a technical capability of 3, which was the lowest among the others, and that was because the way we structured the problem was that the technical capability wasn't a thing for us. And finally, the net terms is 35, which is the second best one that we could have. This was for today's video. I hope you enjoyed that and you may apply this into your life. I've done it in my life. It was great. Many times I was confused with my selections, with my criteria, and what is really important to me. With this, you can mathematicalize, you can quantify some hard choices by numbers, and the numbers always tell the truth. Don't forget to subscribe and like this video. Stay optimized. Good luck.